Hello, my name is Noah Pan Zirgaboon, and I'm doing Southern Cross University's Solving a Wicked Problem, and this is me trying to define what a wicked problem is. Right. So before we know what a wicked problem is, we need to know what a tame problem is. So a tame problem is a very high clarified, lots of information to go around and try and solve the problem. So the problem, for example, let's say, how do we secure cockpits on an airplane? So an answer to that is just straight up pretty much locking the door. Just locking the door. It's that simple. Or I could say that there is no one allowed in this area of the plane, which would be near the cockpit. So when you think about it, the wicked problem for that is how to counter terrorism. And with this, there are so many variables to take into account. There is very low clarity. There is so many nodes or branches that this could stem into. Think of a mind map and say, how do we counter terrorism? And then think of all the ways you can counter that. But then think deeper into those little branches, and you will see that this problem is just more than a simple solution. So a question for that as well is that is it solvable? Is that wicked problem specifically solvable, or has it already been solved? So as you can see, comparing from tame to a wicked problem has so many nodes that it can branch out into, whereas to rather a tame problem is pretty straightforward, has lots of information about it rather than a wicked one that is very difficult to define and has basically no information, right? And you got to think, can it be solved? Can it really be solved? All right. And that leads us straight into our four levels of thinking. This will help us understand how we think about these wicked problems. So the first level of thinking would be me turning on a tap, for example, and let's say water comes out. All right, I get what I want. That's it. That's the first level. And then the second level of that would be the water coming out. How fast is it coming out? Do I have my tap turned to high or low? Or let's say, uh, is the water going to reach the level in about how long that I want it? So let's say I want half a cup. So, and I've already filled a quarter of the cup. Let's say another 2 seconds of the water at this pressure should fill it up. And then the third level of thinking for that is the internal water systems within the household. So all the pipes in the house running from one tap to another, to your showers, to the sewage, all that stuff. And then the fourth level is the supply in the area. So the water treatments, the water tanks, the water towers in your area or city or your suburb, your town. So yeah, those are the four levels of thinking about that. That brings us into linear and complexity. So those examples just then would be a linear way of thinking. So from A to B to C to D. So a wicked problem, think of it more as a complex diagram with lots of feedback loop. I'm talking mind map, loop here, loop here, loop here, loop here, loop here. Lots of loops to go around. There is, and it causes non-linear nodes. So thank you for listening, and I hope you get a better idea of what a wicked problem is.